Hello everyone. Today we are going to learn about material handling. In this presentation, I am going to cover different kinds of conveyors and elevators. Introduction. Material handling equipment is equipment that relates to the movement, storage, control and protection of materials, goods and products throughout the process of manufacturing, distribution, consumption and disposal. Material handling equipment is generally separated into four main categories. Those are storage and handling equipment, engineered systems, industrial trucks, and bulk material handling. Material handling equipment is used to increase output, control cost, and maximize productivity. Definition of material handling. Material handling includes a number of operations that can be executed either by hand or by mechanical means or devices to convey material and reduce human drudgery. Mechanical handling devices aim to lighten the work of human labor. The most common types of mechanical handling equipments are belt conveyor, bucket elevator, screw conveyor, and pneumatic conveyor. In our further slides, we are going to broadly learn about this conveyor and elevator. Before selecting a conveying system, the following principle should be taken. The selection of a proper conveying system is important for ease of operation and getting desired capacity for a particular product. Firstly, conveying device has to be selected according to the characteristic of the products being conveyed. Secondly, stability of the conveyor must be ensured under all normal working and climatic conditions. And thirdly, capacity of conveying and speed rating should be maintained at specified limits. The fourth principle for the selection of conveying system is the dead load of the conveying should be low in relation to the weight of transported products. Then fifth principle is the capacity of handling equipment should match with the capacity of the processing unit. And sixth principle is spillage of conveyed products should be avoided. And the last and the seventh principle to select a conveying system is pollution of the environment due to noise or dust by the conveying system should be avoided. Now come to the belt conveyors. As you can see in the diagram, a belt conveyor is an endless belt operating between two pulleys with its load supported on idlers. This idler term or topic is very important from exam perspective. Most of the time it is asked in the exam that what is idler and what is the working principle. Basically, idlers are used to change the rotational direction of the output shaft or to fill a large gap between the input and output shafts without affecting the speed ratio. The belt may be flat or transporting bag material or V-shaped or some other enclosed shape for moving bulk grains. The belt conveyor consists of a belt, drive mechanism and end pulleys, idlers and loading discharge devices. As you can see in this slide, these are some practical uses of belt conveyors. Belt conveyors have an anti-friction bearing. Therefore, these have a high mechanical efficiency. Design of belt conveyor system. The first step in the design of a belt conveyor with a specified conveying capacity is to determine the speed and the width of the belt. Generally, for grain conveying, belt speed of 2.5 to 2.8 meter per second is recommended. For transportation of grains, the belt speed should not increase 3.5 meter per second. So, these values are very important to remember. Most of the time, these numerical values are asked in the exam. The angle of 20 degree best suited for paddy and most other grains. The capacity of belt conveyor can be calculated by this formula. In this formula, capacity is equal to volume per unit time, that is meter cube per hour, that is by unit, and it is equal to area of cross section. As we know that the cross sectional area's unit is meter square, then it is multiplied with the belt speed, that is the distance upon time, meter per minute is multiplied with 60. The design of belt conveyor system is based on these 5 components. These 5 components are available space, horizontal conveying length, conveying lift, characteristics of the material to be conveyed, and capacity requirement. The majority of belt conveyors for transporting bulk material use some type of rubberized conveyor belt made up of caracases. The pull of load is taken by the longitudinal strength of belt while the transverse strength supports the load. Belt conveyor idlers. The efficiency of belt conveyor is largely dependent on idlers. There are 3 types of idlers. Firstly, idler for 20-degree trough belt. Troughing idlers with 20-degree trough, it is basically used for conveying all kinds of bulk materials. As you can see in the diagram, in the second figure, it is known as flat belt idlers. This is used for granular materials, having an angle of repose of not less than 35 degree. Secondly, idlers for 35-degree trough belt. It is mainly used for the transportation of small particle lightweight materials like grain, cotton seed, etc. It is also used for carrying heavier medium-sized lumps like crushed stones. To serve a specific purpose, the idlers can be self-aligning idlers, impact idlers, and transition idlers. The space between the successive idlers should be approximately equal to the width of the belt. The spacing should not exceed 1.2 meters. Advantages of belt conveyors. Belt conveyors have anti-friction bearing, therefore these have a high mechanical efficiency. There is no damage to material. There is no relative motion between the product and belt. Large carrying capacities and low operating cost. There are also some disadvantages of belt conveyor. Those are, there is a limit to carrying the material on elevation, and a properly designed and maintained belt conveyor has long service life and low operating cost. Bucket elevator. A bucket elevator consists of buckets attached to a chain or belt, revolves around 2 pulleys, one at the top and another one at the bottom, as shown in the figure. The vertical lift of the elevator may range between few meters to more than 50 meters. Capacity of bucket elevators may vary from 2 to 1000 ton per hour. These 50 meter and 2 to 1000 ton per hour, these numerical values are very important to remember because these values are most of the time asked in the exam. The space bucket centrifugal discharge type is commonly used for elevating the grains. This is the practical image of a bucket elevator. Bucket elevators are classified into 2 types. Firstly, space bucket elevators. It is also known as grain leg. Is a mechanism for hauling flowable bulk materials, most often grain or fertilizer, vertically. Second one is continuous bucket elevators. Continuous bucket elevator is a type of bucket elevators designed to carry product all the way between processes gently and without degradation. The spaced bucket elevators are further classified as centrifugal discharge elevator. This centrifugal discharge elevator is used for elevating the grains. Then second one is positive discharge elevator, then marine leg elevator and high speed elevator. The continuous bucket elevators are also classified into 2 categories. Firstly, super capacity bucket elevator, and second one is internal discharge bucket elevators. Design of bucket elevators. The design of bucket elevators contain these 5 components: physical properties, shape and pitch of bucket, and speed. And speed is vary from 2.5 to 4 meter per second. And fourth one is method of feeding, and the fifth and last one is method of discharging. The main parts of a bucket elevator are the elevator head section, elevator boot section. As you see in the image, elevator legs are also important, and belts for the bucket elevator and buckets. The bucket elevator's capacity mainly depends on bucket size, conveying speed, bucket design and spacing, the way of loading and unloading the bucket, and the characteristics of bulk material. There are 4 methods for the discharge. Firstly, gravity discharge. It has the low speed and bucket dopper, and it is a non-adhesive process. Secondly, centrifugal discharge. In this process, small diadrave pulley is used, and it is a high-speed process. Thirdly, positive discharge, and lastly, continuous discharge. These are the diagrams for the 4 bucket elevators accordingly: centrifugal discharge spaced buckets, positive discharge spaced buckets, continuous bucket, and super capacity continuous bucket. Advantages of bucket conveyor are: these are very high capacity, it is dust free and fairly quiet, highly corrosion resistant with a powder coat finish for lasting durability and superior appearance. It requires limited horizontal space. It is a fairly cheap means of vertical conveyance. Screw conveyor. As you can see in the animation, the screw conveyor consists of a tubular or U-shaped trough in which a shaft with a spiral screw revolves. The pitch of a standard screw, which is the distance from the center of one thread to the center of the next thread, is equal to its diameter. For example, a 10 cm diameter screw has a pitch of 10 cm. The screw shaft is supported by end and hanger bearings. The rotation of screw pushes the grain along the trough. This is a detailed diagram of a screw conveyor. The main parts of a screw conveyor are the screw blade, screw shaft, coupling, trough, cover, inlet and outlet gates, bearings and drive mechanism. The thickness of the steel strip helix decreases from the inner edges to the outer edges. The capacity of screw conveyor is influenced by the screw diameter, inclination of the screw blade, speed of the blade, shaft diameter, and cross section of loading. The theoretical capacity is more than the actual capacity because of screw housing clearance and the loading factor. Advantages of screw conveyor. The screw conveyor is used in grain handling facilities, animal feed industries, and other installations for conveying of products, generally for short distances. It is relatively inexpensive and it has the accurate feed rate. There are also some disadvantages of screw conveyor. These disadvantages are: screw conveyor requires relatively high power and is more susceptible to wear than other types of conveyors. Pneumatic conveyor. The pneumatic conveyor moves granular material in a closed duct by high velocity airstream. The granular materials, because of high air pressure, are conveyed in dispersed condition. Pneumatic conveyor is a continuous and flexible transportation method. The material is carried in pipelines either by suction or blowing pressure of airstream. For dispersion of bulk material, the air velocities in the range of 15 to 30 meter per second is necessary. This is the detailed diagram of pneumatic conveying system. The pneumatic conveying system needs a source of air blowing or suction, means of feeding the product into the conveyor, ducts and cyclone or receiving hopper for collection of product. The product is conveyed by using air pressures greater than the atmospheric pressure. The most common type of feeder used in this system is rotary feeder. In this diagram, the main component used are truck unloading auger, then hammer mill feed auger, then hammer mill, ground product bin, diverter, distributor, then elevator and storage bins. The entire pneumatic conveying system can be classified in three basic components. Those are blowing section, feeding section and receiving section. This is the simplified diagram of pneumatic conveying system. Different pneumatic systems are created for various transportation methods. The energy required to move material through a pneumatic conveying system is supplied by pressure differential and airflow. Here, the pressure and airflow used in the conveying line are generated by the system's air mover, which determines whether to generate pressure or vacuum to convey the material. When the system's air mover is placed at the start, the system operates under pressure to convey the material. When the system's air mover is placed at the end, the system operates under a vacuum to convey the material. This manipulation of pressure differential and airflow inside the system helps convey materials from one point to another over certain distance. Here cyclone is a device which removes the bulk of the product particle from the conveying airstream by centrifugal force. In pneumatic conveying system, air mover is a most important component. The selection of air mover is the most important aspect of the design of a pneumatic conveying system. For the selection of an air mover, two factors are considered. Firstly, supply air pressure and secondly, the volumetric flow rate of air. There are also some limitations for pneumatic conveyor. Those limitations are erosion of solid surfaces and equipment surfaces with conveying airstream. In case of bends or misaligned section, the erosion problem becomes severe. The chances of repeated impacts between the particles and the solid surfaces are high. With this pneumatic conveyor limitation slide, I would like to conclude my presentation. Hope you will understand the topic I covered in this presentation, and thank you so much for your attention and interest.